the escapement's influence extended far beyond traditional mechanical clocks. It became a fundamental component in various timekeeping devices, including pendulum clocks, pocket watches, and even early marine chronometers. Its role in regulating time allowed clockmakers to explore new levels of accuracy and reliability. The escapement mechanism is a testament to the ingenuity of clock engineers throughout history. Its development revolutionized timekeeping, making it possible to measure time with unparalleled precision. This mechanical marvel is not only a crucial component in traditional timepieces but also a symbol of our quest for accuracy and the enduring legacy of human innovation in the field of engineering. It laid the foundation for the intricate mechanisms that power the clocks we rely on today, demonstrating how a seemingly simple invention can have a profound impact on our understanding of time. In the 17th century, Christine Huygens introduced the pendulum clock, a groundbreaking development. The pendulum's natural harmonic motion allowed for unprecedented accuracy. The engineering behind pendulum clocks involved precise calculations of pendulum length and weight to achieve consistent oscillations. In the 17th century, the introduction of the pendulum clock by the Dutch scientist and inventor Christine Huygens marked a watershed moment in the history of timekeeping. Huygens' breakthrough was rooted in his deep understanding of physics and mathematics, particularly the principles of oscillation and harmonic motion. The pendulum, a simple yet elegant device, was central to this innovation. The pendulum's natural harmonic motion was critical to achieving the clock's unprecedented accuracy. It swings back and forth in a regular, predictable pattern, known as an isochronous motion. This inherent property of the pendulum made it an ideal timekeeping element, as its oscillations remained nearly constant regardless of the amplitude or width of the swing. This constancy was crucial for achieving precise timekeeping, as it minimized errors in time measurement. The engineering behind pendulum clocks involved meticulous calculations of the pendulum's length and weight. The length of the pendulum, in particular, was meticulously determined to achieve consistent oscillations. The formula for the period of a simple pendulum, T equals 2I diaresis L/G, where T represents the time for one complete swing, L is the length of the pendulum, and G is the acceleration due to gravity, became fundamental to clock design. Clockmakers had to ensure that the pendulum's length was precisely calibrated to the desired timekeeping accuracy. Even slight variations in the length could result in significant timekeeping errors. This required craftsmanship of the highest order, as clockmakers carefully measured and adjusted the pendulum length to achieve the utmost accuracy. Furthermore, Huygens' pendulum clock also incorporated a unique escapement mechanism, which allowed for the controlled release of energy from a wound spring or falling weight. The escapement provided the periodic impulses necessary to keep the pendulum oscillating and ensure the clock's regular timekeeping. In essence, the engineering of pendulum clocks was a fusion of physics, mathematics, and craftsmanship. It represented a remarkable marriage of scientific understanding and practical design. Huygens' invention not only revolutionized timekeeping but also laid the foundation for future developments in horology, inspiring generations of clockmakers and engineers to push the boundaries of precision and accuracy in measuring time. The pendulum clock stands as a testament to human ingenuity and remains an enduring symbol of our quest for ever more accurate timekeeping. Clockmakers later transitioned to spring-driven mechanisms, eliminating the need for hanging weights. The mainspring stores energy, released in a controlled manner through the escapement. The creation of miniaturized, high-tension springs demanded precision engineering skills. The development of spring-driven clocks was a monumental leap in the evolution of timekeeping technology. Prior to their introduction, mechanical clocks relied on the force of gravity, with heavy weights suspended from pulleys or chains to provide the energy needed for consistent operation. This design had its limitations, as it required substantial space and often led to large, bulky clock towers. The emergence of spring-driven mechanisms in the late 15th century, notably during the Renaissance period.